Hello, our most valued student. My name is Confident. Welcome to our Mathematics N3. And in this session, I thought of bringing you some comparison between the paper that was written in April 2020 and comparing it with the November paper. So I just saw some similarities which were striking, and I thought of maybe it might also help you as you prepare for your final exams, be it you're writing your April 2021, your November, or your July 2021 paper. So now let us look at some kind of how were the questions set by the examiners, and how does it compare between the April as well as the November paper. If I can just start with the first part of this question paper. So this is the April. As you can see, this is the April 2020. In actual fact, because of the lockdown and the COVID-19, this paper ended up being written in July 2020. So there were only two papers in this year. The July one, which was initially supposed to be written on the 3rd of April. Again, it is a 3-hour paper, and as you can see, and this was the unique code for this particular paper. As you can see, it was that number. And then there is the last paper, which was written in 2020. It was written on the 16th of November, and also it was written in the morning. That's what it means by saying X paper. It is a 3-hour paper, and also this is the unique code for this particular paper. As you can see, it is differentiated by that particular number. So these were the two papers. If we can look at some instructions, you will notice that the instructions are generally the same between the two papers. This paper had about 10 different instructions, and as you can see, if I compare it with the 20 November paper, it had actually 9 instructions, and the only difference in these instructions, it's number 3. As you can see here, it says in number 3, non-programmable calculators are not allowed in this question paper. You just have to use your normal scientific calculator, not the advanced programmable calculators. Just a normal Casio or a normal Sharp scientific calculator will be allowed. But in this particular instruction, they didn't actually include it. That's why the instructions ended up up to 9, while the April paper, there were 10 instructions in that particular case. Now let us look at the actual paper per se and look at some similarities and some differences in this paper. If I can just make it a little bit smaller so that we can see the numbering. So this was the April paper, and look at question number 1. In this question 1.1, you were actually factorizing. Says factorize the following expression completely, and you were given that expression, and you were given 3 marks for the factorizing of that. And 1.2, it was about the factor and the remainder theorem, and you were using given that f of x is that, which was 5 marks. And 1.3 was saying simplify the following, and you were given the addition of fractions. Of course, it involved some factorization at the denominators, but it was the addition which goes together with the subtraction of fractions. It was out of 7. Now the whole of section of question 1 was out of 15 marks. Now let us see how it compares with the last paper that was just written in November. Now if you look at the November paper, and compare it. Now question number 1, it is the striking thing is question number 1, if you compare with the previous, look at the mark allocation, it is 3 marks, 1.2, 5 and 1.37. And if you look also at the November one, the first question was 3, the second question was 5 and the third question was 7, and the total of question 1 was 15 marks, which is also comparable to the one for April. Let me just write this one and say here, this was an April paper, so that you will know the difference when I move between the slides. So this is April and this is November. So now looking at the April one, as you can see, it started by factorizing and then followed by the remainder and factor theorem. But now if you look at November, they started by using the factor theorem. So this is where it was in question 2, the factor and remainder theorem. And then in question 1.2 in the April one, that's where they did the factor and remainder theorem. And then question 1 was factorizing, and this particular factorizing was a normal basic factorizing in this case. But in this section of November, they wanted you to do completing of a square, which is also factorizing, but in this particular factorizing, you're solving for x with the completion of a square. And if you look at now question 1.3, there were some similarities. In question 1.3, it was dealing with fractions and it was out of 7 marks. And also in the November paper, it also dealt with fractions, as you can see. But now this was the multiplication and the division of fractions, while in the previous section it was the addition of subtrahends, which also works together with the subtractions. But the mark allocation is interesting to say. The examiner wanted to maintain the same mark allocation for these two problems, whereby the total mark allocation was 7 marks. So you can actually see, if you are preparing for your final exams, that the section on fractions, the section on factorization, and the section on factor and remainder theorem are very important sections also as you prepare for your exams. Now let us look at question number 2. Let's start with our April paper. Now in question number 2, this is our April. I will also keep noting that this is April since I have moved the slide up. So now this is question number 2. Now question number 2.1, it says simplify the following. As you can see, there is some form of some exponents here that you have to deal with. So, and it was out of 3 marks here. So you are more like factorizing, but it's in the exponential form, as you can see that it's the powers there. But now if we look at the November question 2, if I can also write here and say this is still our November question 2. Now it was looking at logarithms. Remember, the section of exponents and logs is in the same chapter. So the examiner here thought of actually bringing, instead of those exponents, he thought of bringing in the logarithms. But the mark allocation, if you saw in the previous one, it was 3 marks, and also in the one for 2.1 is 3 marks. So the examiner didn't change the marks between the exponents as well as the logarithms. Now in question 2.2, it says solve for x without using a calculator, showing your working. So it involved the solving for x. Now in this particular solving for x, it was the one that involved logs. Remember, we are moving from exponents to logs. So you're solving for x using logarithms. Also, what is interesting, the examiner thought of not changing. As you can see, it's still solve for x, but the examiner maintained the use of logs in solving for x. It was 4 marks in November. However, in the one for April, it was 5 marks in that case. And then 2.2 in the April one, you are also solving for x using these are the square roots. So how you simplify the square roots. There is a section on Mathematics N3 on how you simplify such questions that involve the square root, and you can see it was 6 marks. And in the November paper, it was now involving exponents. Remember, there were no exponents yet, but the examiner thought of now bringing in the exponents, and this question was now 7 marks. And if you can check carefully, the examiner maintained the total of 14 marks on the 2 sections. There is the this is the April one. I'll keep on writing April. So the April paper, you can see this section, question 2, it was 14 marks. And also in the November, you can see the section 2 was 14 marks. The only difference is that 2.2.1 in the previous one was out of 5 and this one was out of 6, but the balance was 11. In the same manner, this is 4 and 7. So you can see how the examiner was trying to maintain the total of 14 marks in question 2. So what are you taking out of this, or what am I taking out of this? It is very important for you to focus on the section on exponents, logs, and square roots. So this is the sections that appeared in here. If you look again here, it is very important for you to focus on exponents as well as logarithms. Now this is to give you just an idea to say whenever you are studying towards your final exams, what you must be on the lookout for, as they might actually repeat something similar. Then let us look at question number 3, and in this case we will start with the April paper for question number 3. Now in question number 3, this is my April paper. In question number 3.1, it says it involved a word problem. So this is a word problem whereby you are going to solve this kind of a problem mainly using a simultaneous equation. That is what usually happens in question with word problems. And then what about in November? Again, if we look at question 3 in the November paper, I'll just write here, this is a November paper. Now you can see that question number 3 also here, it involved a word problem. So the examiner did not change. He wanted to maintain the word problem. Even the mark allocation, look at it, it was 5 marks in April. It is also 5 marks in November exam. So they still maintained this part on the word problem. And question 3.2, it was the subject of the formula. You're supposed to make one of the items there the subject of the formula, and it was out of 3 marks. Now that is the November paper. It was the subject of the formula. If we look at April exam 3.2, interestingly it says make x the subject of the formula, so it was also the subject of the formula. It's different concepts, but still working on this subject of the formula, and this actually carried more marks. It was 5 marks compared to the 3 marks that you had in 3.2. And then in 3.3, it was more like an extension of the subject of the formula where you are solving for x, and in this is the normal basic equation, but you need to understand how you solve for x. Now this is the November, but if you look at 3.3, it says given that 2 is one of the roots of the quadratic equation, prove that, determine the other root. It's also solving for x. In this case, it's more of a quadratic, and this question had an overall of 15 marks, while that is April, while in November it had less, it had an overall of 11 marks. So it is still similar, it's quadratic in nature, this question. Also, if that is November, if you look at the 3.3, this question also, it is quadratic in nature. So the similarities are still there, where the examiner maintained the quadratic simplification. So it is very important for you if you can learn more on the quadratic equations and their different dimensions, and it is what I usually focus on in my Mathematics M3 lessons, and as well as my Mathematics M3 textbook. I actually deal more on these quadratic differences. Now let us move on to question number 4. In question number 4, this is the April paper, and question number 4, you can say April. The most section on question 4 is coordinate. It's coordinate geometry. I can write spelling there. It's coordinate geometry, which is also similar to this is April paper. It is also similar to the paper that was written in November. Question number 4 always focuses on the coordinate geometry in this case. And then we are saying this particular paper, it is a November paper. So you can see all of them were focusing on the coordinate geometry. They give you some shape or some diagram, which there are questions then that follow. And if we can quickly look at the questions that follow, for example, says 4.1, determine the gradient of the line. So the first thing that you need to understand is you need to know how to find the gradient. This is still the question for April. And if we look at the November one, the questions are for November paper. I can just show all of it. So this is the November. Again, look at the striking similarity. The questions start by asking you to find the gradient, and then the next part it wants you to find the angle of inclination, that is size B. And then if you look at the November paper, actually it requires something different. It's the equation of AC in the form of y is called the mx plus c. Now usually they ask you such questions later, as you'll see, but let's look at 4.3. 4.3 says the length of the diagonal line of the quadrilateral. So they want the length or the distance, so in which you're supposed to apply the distance formula. And if you look at 4.3, there is the length, which also wanted you to apply the distance formula. And then the equation of EF, that's 4.4, says the equation of the line. So you see there are questions that want you to find the equation of the line, and that is passing through point D, that is perpendicular. So we have an equation of a line, and you're given something to do with perpendicular. And if you look at this particular part, they told us about something also that has to deal with the perpendicular, the equation of BD. Now if you look at BD, they will tell you also some information that they said BD is perpendicular to AC, as you can see that. So there is a concept that you need to know about perpendicular lines, and not only perpendicular lines. If you can see on this part, there is the parallel lines that also they wanted you to use that concept of. So that was the November. Now looking at the April paper, the equation of the line passing through point C, that is parallel. As you can see, there is the word now. So after perpendicular, they asked you to deal with the parallel line, which also in the November one, there is a parallel line. They didn't state it, but the parallel line is EF, and you can see that they want you to find the equation of EF, and this is the part which is parallel. And in BD, we said it was the part which was perpendicular. So in as much as the questions were asked in different order, but you can see something striking or something similar is that the part of perpendicular lines and parallel lines is something that you cannot just leave for granted. And then says leave the answer in the gradient intercept form here, and then also previously leave the answer in the gradient intercept form. And what is interesting is in this one they were saying the equation of the line in the form y is equal to mx plus c. This is actually the gradient intercept form. Even here they also want you to do the same, to say y is equal to mx plus c, which is the same as the gradient intercept form. And then the last question was the coordinates of D. In this case, it wanted you to solve a simultaneous equation. If I can look at the one previously, says the coordinates of the point of intersection. You can see there is that part, intersection of the following two given lines. So if there are two given lines and they are intersecting, it's more like simultaneous equations. It was 3 marks in this case. Even in the November paper, the coordinates of D was actually that particular point that they wanted, which was a point of intersection between the two lines BD and this particular line, I think it's AC. You can see that that is a meeting point of that. So you have got that line and that line. So this is actually the coordinates of the D is actually the coordinates of the point of intersection between BD and AC. And if we can try to see on the diagram, if ever they gave us more information, says the calculate the following: EF is parallel to AC and BD is perpendicular to AC. It's perpendicular, okay? AE is called to AB. But also that coordinates of BD, remember, it is actually put in a simpler way in 4.6 in the April paper. It says the coordinates of the point of intersection. So that is the point of intersection between two given lines. So you can see there is also a similarity in the coordinate geometry. If you can master a few things like the gradient formula, the distance formula, the length, what actually they brought in here in this particular question. Let me see if they brought it. There isn't much of the midpoint, but if you look at this coordinates of B, which is 4.5, now they told you that in this case EP is equal to EC, meaning this is the center, and you're supposed to use the formula for finding the coordinates of the midpoint for you to be able to find B. I will be covering this in the later sections. Just check it out how you solve for the coordinates of B, but this uses the midpoint. So again, you need to know the gradient. In this case, know your gradient, know your length, know your midpoint there, know the equation of the line in the form of y is equal to mx plus c, or in the gradient intercept form, as well as the point of intersection is also important in this part. Let us look at question number 5. Now in question number 5, mainly it is a question that involves some differential calculus, and then let us see how these questions are fared or were different from each other. The first 5.1 says draw the graph of the following equation on the answer book. Calculations do not need to be shown, all values at the point. So you're drawing a graph here of a different of different graphs. These are also given in your mathematics N3 book. I'll also cover them in detail how you can simply sketch this equation. They are actually very simplified. But now in our 5.1 of November, remember this was our April. Now let's look at the November one. In our 5.1 of November, they actually didn't bring any sketching. They started by straight going to determine dy over dx, which is your calculus now in this case. And if you look in the previous one, that is what they brought under 5.2, which is that particular part of calculus. Says determine dy over dx of the following. Now something striking on this is its exponents, which are fractions, and it is out of 5 marks. And if you look at the November one, it's also exponents which are fractions, and in terms of in fraction as well as exponents with the square root, also it's exponent to the power of a fraction. So these are very similar, and strikingly it's this had more marks than the other one, but the way you approach this dy over dx for on both sides of whether it was the November or the April one, it is actually similar way. They are very similar in nature. If you can just grab hold of your mathematics N3, and if it is not covering, you can check my lessons where I cover these in detail. They are actually similar, and these 6 marks are for grabs. The only part that they are trying to find out here is your knowledge of exponents. In this part, even in here, it is your knowledge of exponents. So that is when they are tying in the loose ends to check if your exponents are in sound check. Now let us look at 5.3. 5.3 says you are given this particular f of x, and then says make use of differentiation to determine the coordinates of the turning points of the graph of f of x. So in this particular case, you are using number 1, differentiation. Number 2, you are finding the coordinates of turning points. So that is the key part. Let us look at this was April paper, remember? Write it down here. It was the April paper. Let's look at the November paper. The November paper also, you are given a function like that, and then says determine the coordinates. There is the question coordinates, and then it says turning points. The only thing they didn't include is make use of differentiation, but for you to solve this question, you also must make use of differentiation to find the coordinates of the turning points. You are given 5 marks if you answer that. Even in this section, actually it's a similar question. It uses the same concept, and that's why the marks were the examiner actually maintained the same marks. So knowing this particular section of finding the turning points using differentiation is actually very important in that. And then 5.3.2 says draw the graph of the given equation, and then so there is the graph part, and then in the graph they wanted to show the point of intersection with the system of axes and the coordinates of the turning points. That is the April one. The November again, instead of drawing, they say sketch, which is similar. You're sketching the graph of f of x, and then says and show the calculated values. So in other words, they're saying show the coordinates of the turning points. And then actually 5.2.2, they wanted you to calculate the x and the y intercepts of f of x, which is 3 marks, which in the April paper they didn't bring that particular question. They just said make use of this to find the turning point. So in here, when you were sketching the graph, you needed to find the x and y intercepts. So it is actually part and parcel of in a way it is a question that was a bit unfair, whereby for 4 marks they needed you to find the x and y intercepts, and in November they are giving you 3 marks just for calculating the x and y intercepts. And then after that they're saying sketch the graph and they're giving you even more marks now after sketching the graph, because these two questions were identically the same. So in total, question 5.2 was out of 13 marks. It had more marks in November than in April, where it was out of 9 marks. So it's more like 4 marks more different than the other one, which I would say then it's always good for you to go prepared how to sketch the graph of a given function using differentiation to find the coordinates of the turning point, know how to find the x and y intercepts, as well as being able to just to sketch those graphs. Now moving on, question number 6. Remember, this is November. Already this is our November here. So there is question number 6 for November. Just look at this one. It says use basic trigonometric identities to simplify the following. This was a question out of 6 marks, and it involved quite a lot of trig identities. It was the reduction rules that were mainly needed in this part. So you had to use a lot of your reduction rules. Now if you look at the April paper, as it started on a fresh page, now the April paper is also, question 6 is on trig, says also make use of basic trig identity to prove that. So here it was mainly on proof, it's 5 marks. The other one, if you remember previously, remember this is April. Now the other one previously, the November one, was also saying trig identities, but it was using reduction rules. But the April one actually is using trig identities to actually prove what the left hand side is equal to the right hand side. Now, which is important for you to know both, because any of them can come. 6.2 says calculate the values of x that will satisfy the following equation. So here you are more like solving for x in trig. Now if I can check that 6.2 in the November paper, they actually gave you a totally different question. They gave you a question, if you can see, they gave you a diagram, and the question now was a calculate the length of BD and of AB and the length of BD. Usually when you are calculating the length here, it is application of trig, where you use sine rule, cosine, and trig ratios here. So that is mainly what is used whenever you are given a triangle to solve. But if you look in this question, they were actually wanting you to solve for x, which was totally different. Now the next part is question 6.3. It says you are given this particular part, and then they are actually talking about the angles. There is the angle of elevation. I'm just looking at that word there. Whenever this question comes, usually they talk about the angle of depression or the angle of elevation, and used from that they want to determine h, the height of the building. And here the concept also is application of trig, and the concept that they will bring in here is trig ratios. So if you know your trig ratios, you'll be able then to solve that, which is similar to this particular diagram where they were using trig ratios to solve that, as well as the other two sine or cosine rule. And moving on, the next question, it was 6.4, and this is, remember, this is still April paper in this case. Now question 6.4 says draw the graph of f of x is that. We are drawing the graph showing the coordinates of all the turning points and the intercepts with the axis. So there is a drawing of graph where they give you the trig part, the function, as well as the domain of that particular graph. Then it says showing the coordinates of the turning points and the intercept with the axis, giving you 6 marks. If you look also in this particular question okay, looking at 6.3, 6.3 is solving for theta, for angle. In other ways, they could have said solve for x, which is similar to the one that we looked at previously. That is question 6.2, which says calculate the values of x. So they could have said calculate the values of theta. They give you that range there. And in this particular question, they say calculate solve for theta, and they give you the range 0 to 360, and you are solving for x. That is 4 marks. Now then from 6.4, it is where now they are saying the function is given by that, and then there is the sketching of that particular graph where you have to sketch, and then they are again saying showing the coordinates of the turning point and the intercept with the axis. A similar question that we saw on 6.4 here, which says draw the graph and then showing the coordinates of the turning points and the intercept with the axis. So it was 6 marks, but in this particular question, you were actually, to draw that, you were getting 4 marks. And there was an extra question now, an interpretation of the question on the graph says write down the x coordinates of the point at which that is that, and you get 1 mark. But if you look at the total of section of question 6, it was 21 marks, which is also similar for the April paper, which was out of 21 marks. Now you already know that your mathematics N3 is 1 hour, and it is out of 100 marks whenever you are solving. So this means this was the end of the question paper. And don't forget, in your question paper they always give you the formula sheet. So these are 2 pages of the formula sheet that they provide, which most cases it is similar stuff. It's just a basic formula sheet which has got all these areas that is being included. So this is the first page, and the next page of the formula sheet is also that part. So it is always important for you to know these formulas and how they can become handy for you in your final exam. Now, as I said, the main part of this particular lesson, as we were looking at different, November and April paper. So the main part was in comparing this between the April paper and the November paper and how it was different. And in a way, I can see a lot of similarities between the 2 papers. It is not surprising that somehow the examiner might be the same examiner, or the person who set the November paper was doing it with a reference to the April paper, because the similarities are just striking. So whenever you are revising, it will be good also to look at the April and November papers. Of course, you need to go through all the previous papers to gain an understanding how they usually bring in their papers. But a person who did an April paper as their preparation, I think, was not disappointed when this particular exam came. Remember, you cannot spot an exam. The preparation is always better, because they say luck favors the prepared. So I'll never advise you to spot a paper whereby you revise only one question paper and you expect that the other exam will be similar, because that would be catastrophic for your final. I will encourage you to do as much revision on previous papers as possible. And also, I have got my Mathematics N3 for the Underdogs, which is one of the best-selling books at the moment. And with that book, it will give you a lot of strategies, and it is more aligned to the current changes in the curriculum, the way they are bringing in the N3. It is always the same syllabus, but the way that they are bringing them, they are kind of you can see a certain pattern which they are following, and the book is actually aligned to the current pattern. The syllabus has never changed, but the pattern or the way they are approaching the questions is what the book is on. So I will encourage you to grab hold of the book, or it is also comes in video form, so you can actually subscribe to our channel and get most of these videos so that you can further prepare for your final exams. I hope this was of benefit to you. If you have got any questions, any ideas, or anything that you think you can put across, please feel free to leave us a comment, or you can send us an email on the details that will be given later in this section, and we will greatly value your input, and we will also respond to your questions should you have any. We have come to the end of our lesson. Thank you.